All right, welcome back. So we're getting near the end of it. We don't have too much more to go. But this is number 11. Okay, it's consider the polar coordinate curves. Here we go. Sketch the graph of the two curves on the same coordinate plane. I mean the polar coordinate plane. Determine your points of intersection and figure out the area inside the circle but outside the limacon. Okay, so let's have a look at what's going on here. Actually, hold on. I think I need to pause for a moment. See, I told you she was adorable. Okay, but she's very loud, so she's got to go in the bedroom for a while. She also doesn't like being held, so this is going to be... All right, well, that might work, that might not. All right, so where were we? We were graphing some polar coordinate graphs. So the first one, right, this is r is equal to 5 sine theta. So this is just pretty much a sine graph, isn't it? We're just going to go from 0 to 2 pi, pi over 2, 3 pi over 2. I know, anybody who's had me before knows, like, why do your graphs all look the same? Because it's just about the scaling. All right, so here we go. Okay, pretend this looks like a sine wave. All right, not too bad. Okay, who am I kidding? That was terrible. And then we have r is equal to 2 plus sine theta. So here's what we're going to do with that. Here's your theta, here's your r. Here's 2. We're going to kind of make a new axis here. Here's 2 pi, here's pi, pi over 2, 3 pi over 2, right? Because really it's just, 2, and then the sign dances around the 2 line here, y equals 2 line. So it goes up, goes down. Oops, no it doesn't, it goes back to 0, goes down, and then back here. So here we go. Okay, and again, oops, misjudged that one. So let's try it again. So we have here, and then here, and then here, and then here. Okay. So I'm going to use these to kind of get a polar coordinate graph here. Again, the before time I could use like an eraser or something on the board to kind of help scale it, because unfortunately we are going to need a scale, a better one than I can draw to kind of get this one. Okay, it's 0, not pi, not theta, it's just 0. Okay, so we'll try this. We'll say 1, 2, 4, 5. 1, 2, 3, 4, 5. Should give myself some more room. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. All right. So we'll try drawing the first one. Right. This will be r is equal to 5 sine theta. So when theta is 0, the r is 0. Great, we get to start here. As theta sweeps over to pi over 2, we are sweeping all the way up to 5. So we're going all the way up here. Okay. This is supposed to be a circle. Okay, so please use your imaginations. All right, and then once we get to pi over 2, it's going to sweep back down to pi. All right, that looks a little bit better. And then when we get over here, right, we're like pi over 3, or 3 pi over 2 rather. We should be down here, but it's negative, so we're actually up here again. So this is a circle twice. Okay. Now, this guy here, right, limacon. So when theta equals 0, we are up here. Let's come up with a different color. Okay, so this will be 2 plus sine theta. So look here, when theta is at 0, right, then r is actually at 2. That's where we end as well. Okay. Now, as we sweep forward, right, we sweep through the angles here, we're actually going to be getting all the way up to r is equal to 1, 2, 3. Okay, so we're going to go ahead and put something like this. All right. Again, it's supposed to be more round than that, but use your imaginations. Okay, and as we get to back to pi again, right, we're going to be at pi, so we're going to be going back down over here. All right, I see some intersection points, poorly drawn, but there's still some intersection points. And then once we get down to pi, right, we're down here someplace, but these are still positive numbers because it's, you know, we're up here. So at 3 pi over 2, we're here at 1, right? This is 1. So what's going to happen is we're going to get this kind of flattening here, right? And that's our limacon. Okay, so we're here and we're here. Those are our 2 points of intersection. Okay. So how do we do that? Well, what we're going to do is we're going to say 5 sine theta must be equal to 2 plus sine theta. Oh, they're both sines. They're both single. The arguments are both theta. Wow, somebody must really love me to come up with a problem this nice. Okay. Sine theta is equal to 2/4, which is a half. So it comes out just like it came out of a textbook almost. Wow, what a beautiful problem. So where is sine theta equal to a half? Right? Half would be like down here somewhere, right? It would be here and here, right? This would be a half. It would intersect in these 2 spots. Those are going to be, right, pi over 6 and 5 pi over 6, right? So it's positive a half. It hits in 2 spots. It hits in 2 spots. All right. So those are the points of intersection. Those are going to be my limits of integration. When I go ahead and do my integral, it's pi over 6, 5 pi over 6. Okay. Now, what we're going to do is we're going to take the brown area minus the pink area. Okay, or I guess copper. I would call that copper. The copper area minus the pink area. Okay, because I wanted to go outside the limacon but inside the circle. So what they're looking for is this. Okay, that's what we're looking for. So what's the area of the big circle there? Well, it's 1/2 r squared theta. 1/2, and r squared is going to be 25 times sine squared theta, right? Let me make that a little bit bigger. That's terrible. All right. Do that twice maybe, and then go back to this. So this is going to be 1/2, 25 times sine squared theta. Okay, that's my big area. What's the little area? What's the limacon area? Well, it's 1/2 r squared d theta. It should be a d theta here. All right. So that's 1/2. R was 2 plus sine theta d theta. All right. I'm starting to take this back. Maybe the person who came up with this problem isn't so nice anymore. That's 4. 2 and 2 make 4 sine theta plus sine squared theta. All right. So we're going to take this area minus this area. Okay. So going through with my integral, that's 5. Oh, no, it isn't. It's pi over 6. It's pi over 6. 5 pi over 6. Okay. And we have the big area. So this is 25 over 2 sine squared theta minus, well, can I just go ahead and factor this through? So it's going to be minus 2 sine theta minus 1/2 sine squared theta. All right, I just multiplied it to 2 in here, and factor the negative sign in there as well. Mostly because I want to do this. 25 over 2 minus 1 over 2 is 24 over 2, which is a fancy way to say 12. So we have 5 over 6, 5 pi over 6. And here we have 12 sine squared theta minus 2 sine theta minus 2. Okay, but I can't integrate that. Maybe the person who wrote this was a jerk. Okay, but that's not too bad, right? That's sine 2 or cosine 2 theta is equal to 1 minus 2 sine squared theta, right? So that's 2 sine squared theta is equal to 1 minus cosine 2 theta, and sine squared theta is equal to 1/2 1 minus cosine 2 theta. Okay, that's not so bad. Okay, I take that back. Not a terrible person yet. Okay, pi over 6, 5 pi over 6. We have 12. What are we doing here? Right, there's 12 times 1/2, 1 minus cosine 2 theta, minus 2 sine theta, minus 2. Okay, so 12 divided by 2, right, that's 6. So what we're going to have here is pi over 6 to 5 pi over 6. We've got 6 minus 6 cosine 2 theta minus 2 sine theta minus 2. And there's, of course, a d theta at the end of all of this mess. So one more cleanup to go. Okay, and then we'll get to integrating. Pi over 6, 5 pi over 6. 6 minus 2 is 4. Right? Minus 2 sine theta minus 6 cosine 2 theta. Okay. Now we'll integrate. So that's going to be 4 theta minus, well, derivative of sine is cosine, so the integral, right? Oh, wait a minute. Now the integral, the derivative of cosine is negative sine. Okay, so the integral of cosine must be negative sine. Okay, so that's how we do that. Derivative of sine is cosine, so we integrate that. We just get back to the regular, so that's going to be 6 sine 2 theta times 1/2. Again, if I guess and check this, right, the derivative of sine 2 theta is going to be, derivative of sine is going to be cosine 2 theta times 2 because of the chain. The 2 and the 1/2 are going to knock each other out. So we'll be back to where we started. So guessing and checking this. If you need to use a u substitution, by all means, use the u substitution. Okay, don't let me tell you, right? Don't let me try to shame you into doing it a way you're not comfortable with doing it. I want you to be very happy doing your integrations here. I'll shoot that out. All right, we're gonna take a moment here. Resume. There we go. Hopefully she won't get out now. Okay, we have to go through and do a lot of arithmetic, right? Because this isn't a 0. We're stuck with actually doing arithmetic. So if I plug in, right, we'll make this the 5 pi over 6 line. So 4 times 5 pi over 6, could I say that that's 20 pi over 6 plus 2? What's the cosine of 5 pi over 6? Right. 5 pi over 6 is over here, so it's in quadrant 2. It's going to be negative. So it's going to be negative square root of 3 over 2, because our reference angle is pi over 6, or 30 degrees. Cosine is big there. Okay, minus, and then we have 3 sine. We're going to have 3 sine of 2 times, that's going to be 10 pi over 6. That's over here somewhere, right? That's in quadrant 4. So this is also going to be negative. Okay, this is going to be negative because it's in quadrant 4. So that's going to be a negative 1/2. No, it isn't, because this cancels. So it's a pi over 3. And sine of pi over 3 is also a square root of 3 over 2. Right? And let's go ahead and account for the negative because it's in quadrant 4. Okay. Pi over 6. By the way, I really have no care about how you guys evaluate this stuff. If you are comfortable punching this into your calculator and going for it, then you go right ahead and do that. Okay, here we have 4 times 4 pi over 6. We're going to call this 4 pi over 6 here, right? And then plus 2. And this is cosine of pi over 6. That's just square root of 3 over 2. Okay. And then this will start off like there's a minus, right? There's a minus. And then we have 3. And again, if I multiply this by 2, that's going to be 2 pi over 6. It's pi over 3. That's first quadrant stuff. So this is just going to be square root of 3 over 2. That's what my sign is there. The reason why I did it this way, okay, the reason why I did it this way, we'll move this negative sign out here, was because look how beautiful this is, right? Maybe I'll go back on my thought before. And it's like, wow, what a great problem somebody laid out for us here. Negative and positive, that's 0. Positive and negative, that's 0. So here we have it. We have 16 pi over 6, right? And if I cast out a 2 here, that's going to be 8/3 pi. That's what the that's how the numerology people say it. They cast out 2s and they cast out 3s. Okay, so that's their lingo. All right. So numerology is fascinating. It's terribly wrong, but it's fascinating how they do things. But there's our area. Okay, so that's fantastic. I actually do rather like problems like this. They're not really that difficult. And if you set them up well, then they do come out to be pretty good. Okay, so there we go. I'll meet you back for the next one.